This is review 1.6 to 1.9. Let's graph the function. We have f of x equals 1/2 third root of x minus 1. Let's graph the parent function. Third root of -8 is -2. Third root of -1 is -1. We got 0 and 1. Third root of 1 is 1, of course. Third root of 8 is 2. Now the 1/2 on the outside means we're going to shrink vertically by a factor of 1/2. So let me grab a different color here. So we're going to shrink vertically by 1/2. And then everything to right one, to the right one. So right one, right one, right one, right one, right one there. And now we play connect the dots. The next one is a parabola. And let's factor out the 2. So now we reflect over the x-axis and we shrink horizontally by 2. So let's just reflect over the x-axis. So here, 1 and 1, 2 squared is 4, 2 squared is 4, 3 squared is 9, 3 squared is 9, so that's from the vertex. The 2 on the inside, this 2 right here, shrinks horizontally by a factor of 1/2. So here, there's the half of 2 is 1, half of 3 is 1.5. Now we got to take all of those and move them 2 to the right. So 2 to the right. Like this, 1, 2 there, 2 there, 1, 2 there, and 2 over like that. There we go. Given y equals square root of x, write the new function given a horizontal shrink of 1/2 for reflection over the x-axis and up 4. Horizontal shrink over the x-axis, that's outside. Horizontal shrink of 1/2, that's 2x, and then up 4 is plus 4. If the parent graph is the third root of x, give the equation of the translated graph. Well, I know that this is the center of the third root of x, and it's usually over here at 0, 0. So we've gone left 3 and up 2. Left 3 and up 2. Now, the third root of 1 is 1, and we've gone over 1 and up 1, so this hasn't been stretched or shrunk in any fashion. You might want to also consider whether it's been reflected over the x-axis or the y-axis, and this has not. It still maintains that third root of x shape. State the domain in interval notation. Denominators cannot be 0. So x cannot be -6 and x cannot be 3. So negative infinity to -6, -6 to 3, union with 3 to infinity. Over here, 3x plus 12 has to be greater than or equal to 0. So let's solve this. -4, so -4 to infinity. This one is just negative infinity to infinity, and 7x minus 4 here has to be greater than 0. It can't be equal to 0 because this is in the denominator. So we'll add the 4 over, so x is greater than 4/7, so 4/7 to infinity. Given f of x is x minus 2 and g of x is x squared plus 3, complete the operation and state the domain. So f plus g. X squared plus x plus 1, then negative infinity to infinity would be the domain. So f, and I made this, I want to make this -3 to make it a little bit more interesting. So x squared minus 3. And now x squared minus 3, that can't be 0. So let's find out where it's there, 0. So the domain would be negative infinity to negative square root of 3, union with negative square root of 3, to square root of 3, union with square root of 3 to infinity. G into f. So G into f would be x squared minus 3 minus 2. So x squared minus 5, negative infinity to infinity. F into g, let's go the other way with it. That'd be x minus 2 squared minus 3. So x squared minus 4x plus 4 minus 3. X x squared minus 4x plus 1. Negative infinity to infinity would be the domain on that one. Find f of g of x and give the domain. So we'll put that into here. So f of g of x is 3 squared x minus 2 minus 1. So x minus 2 has to be greater than or equal to 0. So x is greater than or equal to 2. So 2 to infinity. Let's make f of x equal to 8 minus x and g of x equal to 8 minus, no, not 8 minus, absolute value of x plus 2. You could probably do another one here. You don't have to have both of these. So 8 minus absolute value of x and g of x would be x plus 2. So that's another option. Find the inverse of each function and give the domain. So x equals 2y minus 1, so 2y equals x plus 1. Y equals x plus 1 over 2, so that's the f inverse. And the domain for this, negative infinity to infinity. It's a line. Here we have half of a parabola. So 1, 2, 3, 3 to the right. There's the graph of f of x. So let's do the inverse. Have an announcement going on. I don't want that to blah blah blah. I don't want that any names on this or anything. So hopefully you couldn't hear that. Anyway, y minus 3 equals x squared. So y equals x squared plus 3. But look, we only have half a parabola. The domain for this one would be 3 to infinity, and the range would be 0 to infinity. So the domain of the inverse, and I got to write inverse here, inherits the range of the original function. So the domain for this has to be 0 to infinity. So if you're only graphing half a parabola here, the inverse can only be half a parabola. Let's switch x and y here. So let's multiply by y plus 2. That gets rid of the fraction. Let's distribute xy plus 2x equals 2y minus 1. Let's get the y's together and factor out the y. Well, now we've turned two y's into 1y. So f inverse of x equals negative 2x minus 1 over x minus 2. We can't allow the denominator to be 0, so we'll skip over 2. Find the inverse, graph the function, and the inverse. Let's graph the inverse first. And I notice that x has to be greater than or equal to negative 1. And for the parabola, we've gone left 1 and up 1. So over 1, up 1, over 2, 2 squared is 4, 3 squared is 9. So there's half of that parabola. Let's get the inverse here. So y plus 1 squared equals x minus 1. Now when we take the square root, since we have the positive half of the parabola on the original, we need the positive half of the parabola here on the inverse. So f inverse of x, instead of having plus or minus here, we just have the plus. Square root of x minus 1 minus 1, so we need to go right 1 and down 1. Right 1 and down 1 from 0, 0, then square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And notice that's a perfect reflection over the line y equals x. Write the standard form of the equation of the circle given center negative 2, 3 and radius 5. Well, this is just the Pythagorean theorem. It says a squared plus b squared equals c squared. And then on here, we're going to write the equation. We're going to make this look like that. Plus blank, y squared minus 8y plus blank. So we'll get the x's and the y's together. We'll get that 16 to the other side and complete the square. So 6 divided by 2 is 3, and 3 squared is 9. 8 divided by 2 is 4, 4 squared is 16. So we have x plus 3 times x plus 3, y minus 4 times y minus 4, and then that's equal to 9. So the center for this would be negative 3, 4, and the radius is 3.